Can you hear me, Soumya?
Yes, I can.
All right. So H2PO4 negative, it's an acid and it is going to react with the base. All right. And when it is going to lose one hydrogen ion, it changes into HPO4 negative 2. That is very important. I can explain you. Let me write it. HPO4 negative, right?
Mm-hmm.
H2PO4 negative. Now, actually, you know what? This is after losing one hydrogen ion. That means one positive ion would be lesser. This is three negative. PO4 is always three negative. Are you getting my point? So, what is going to happen, Bete? When one hydrogen ion would be given, it is going to go to F, this F. And when it will go to this F, it changes into HF. Now, one hydrogen ion is given to F. What it is left with now, it is left with one hydrogen and PO4 negative. Now, you know that why this charge hand has been increased because PO4, let me tell you that H 3PO4. This is the correct thing, right? So this is plus 3 minus 3. Phosphate has a charge minus 3. You need to memorize it. But we don't have phosphoric H3PO4. We have H2PO4. Actually, the parent is H3PO4. Have a look now. This positive 3 would get cancelled with this negative 3. But if I am going to reduce one hydrogen as given here, so I need to write H2 PO4. Now, this is negative 3. Are you getting my point? And this is positive, positive, 2 positive. All right. So, that is what is going to happen because one hydrogen ion has been given. So, out of 3, 2 are here and one hydrogen ion is given. So, it is not there. So, there are 2 positive charges and 3 negative charges. If I write 3 negative charges like this, then check it out. Plus cancelled by minus, plus cancelled by minus. So what is left? One negative charge which is shown here. Does it make sense?
Yes, it does.
Good. Now, when you are going to lose one more hydrogen ion, then what is going to happen? Have a look. H, it changes into HPO4 to negative. Now, this is 2 negative, but I'll tell you how this is 2 negative. So this is negative 3. And how many hydrogen ions are there now? H plus, one hydrogen ion. So, and now let me write it like this, 1 plus, and how many negatives are there? 3 negatives. So 1 plus would be cancelled by one negative, and how many negative charges are left? Two negative charges are left. Where can you see these two negative charges? Be very careful. Where can you see these two negative charges? Here.
Okay,
Is
so
it?
it
Is
transfers.
yes?
Yes.
No, no, no. You were asking something.
It it transfers the negative charges.
It doesn't transfer. Have a look, Somya. It doesn't transfer. Actually, look. I'll do it here in front of you so you can see again. I'm telling you, Beta, with H3PO4. This is called as phosphoric acid.
Right.
Phosphoric acid. This is the formula. Now, how this formula has been made? You know about the crisscross method, right?
Yes.
Actually, you have to learn that phosphate ion is minus 3. All right. And now, if phosphate ion is minus 3 and you want to make a compound with hydrogen ion, how many hydrogen ions should be there in order to make it neutral? Hydrogen ion, which carries a positive charge. How many hydrogen ions should I have to make this neutral and getting a zero charge on it?
3.
3. So I have to write H3. Then what is going to happen? 3 times plus 1 would be equal to plus 3 and minus 3, it will get cancelled. This is a one way. The other way is if I write HPO4, I know that the charge of PO4 is minus 3. I know that the hydrogen is in group 1. So the charge on hydrogen is plus 1. Now you know about the crisscross method. This will go down and this will go down here. So what would be the formula, Somya? This 3 is going to come down here. PO4, this one is going to come down here. It doesn't make any difference. So we are going to have the formula H3PO4. Does it make sense now?
Yes, it does.
If not, I can explain again.
No, I understand it now.
Well done.
It's to
Now,
neutralize
now
the
what?
charge.
Yeah, yes. And now what is given in your question? The question is given as H2PO4 negative. H2PO4 negative. H2PO4 negative. Here it is, right? Now, H2PO4 is given as negative. Now, what is going to happen, beta? It is going to, if it's an acid, it will lose a hydrogen ion. Yes or no? Yes.
Yes.
So how much
Yes.
hydrogen ion will be left? One hydrogen ion. So after losing one hydrogen ion, it will be HPO4 negative, right? But you know what? Why this is negative 2? The reason being, originally just think that it doesn't have any charge, right? Originally it was minus 3, all right. And it is right now, it is plus one. So if you are going to write it like this and plus, one plus will be cancelled by one negative. And how many negatives are left? Two negatives are left. So where these negatives have been shown here.
Okay.
All right. No, I think it's still not clear to you.
No, it's making sense. The hydrogen, there were two hydrogen ions, and then it transferred one because it's an acid. So you're left
Hmm.
with HPO4, and then the charge was originally -1, but because that one hydrogen ion had been transferred, it's now HPO4 2 minus.
Yeah, or in other words, you can start from the beginning, Somya. HPO4 minus, HPO4. You know that the charge on phosphate is -3, and if there is only one hydrogen, then it is +1. So -3 means three minus charges. +1 means only +1 charge. So one plus will be cancelled by minus, and how many charges would be left on PO4? Two. So it would become HPO4 minus two.
Okay.
Yes. Now, if you
Yes.
have, let's suppose, now you tell me, if you have H2PO4, right? Write only the elements. So H from this side and PO4 from this side. Can you tell me what is the charge on PO4? Total charge.
2 minus.
-3, beta, -3, originally.
Oh, okay.
Originally -3. So like this. And how many hydrogens are there? What is the original charge on hydrogen? Original charge +1. And how many
Plus,
hydrogens are there? Two. So I need to
yeah.
multiply it by two.
Yes.
Yes. So how many total
Mhm.
positive charges? Two positive and three negatives. Now start cancelling it. Plus minus plus minus. So what would be the overall charge now? HPO4 minus, because one minus is left. Yes or no?
Yes.
Now have a look. This HPO4 minus.
Got it.
Mm. Yes,
Yes.
HPO4 minus. Good. Well done. So should we start the next question now?
Yes.
Okay. All right. Identify the Bronsted-Lowry acid in model 2. This is model 2. So always keep this thing in mind. I'll write it here. Acid is a proton donor. Base is a proton acceptor. Now, let's do this. Identify the Bronsted-Lowry acid in model 2. You simply need to identify the acid. Atoms of
Oh,
which elements are present in all of the Bronsted-Lowry acids in model 2? Which atoms which is representing the acid? For example, in this, which thing is representing the acid?
HPO4.
No, which thing is representing the acid? Only
Oh, the
H.
hydrogen.
Hydrogen. So what is the answer here? Hydrogen. Are you getting it, Somya?
Yes. So this is only for Bronsted-Lowry, not for
Yeah.
Arrhenius.
Yeah. No. Arrhenius is something else.
Okay.
Okay. How can you tell from reaction 1 that HCl loses an hydrogen ion rather than a hydrogen atom when the reaction occurs? So have a look. In reaction 1. So this is reaction 1. Let me rub this off so that you'll get a clear idea. This is reaction one. Have a look now. He's saying, how can you tell from reaction one that HCl loses a hydrogen ion rather than a hydrogen atom? How can we tell just by looking at this reaction?
Because the charge changes.
No, till charge, your answer was correct. You need to say, beta, that the charge comes in the product. This how this charge has come, because hydrogen ion has been added to this. If I simply add hydrogen, it becomes H3O. There would be no charge on it. But as I am moving hydrogen ion, so when hydrogen ion is added to the base, it changes into H3O positive. This H3, this positive charge actually tells you that the species which has been transferred has a positive charge. Otherwise,
Okay.
otherwise, beta, this is neutral. This is neutral. There is no charge on water.
So
Hmm?
the charge appears in H3O plus. That means that H2O lost a hydrogen atom.
No, no. H2O gains the hydrogen electron, hydrogen ion.
So
Beta, have a
H2O
look.
gains a hydrogen ion from HCl.
Yes, have a
And
look.
then Cl loses
H
the hydrogen.
positive, yeah, hydrogen ion from hydrochloric acid will go to water. When this
Right.
hydrogen ion adds to it, this species gains a charge.
And then then the HCl becomes Cl minus because it lost a hydrogen, so now it has a negative charge.
It lost a hydrogen ion.
Yes.
Have a look. HCl. What is the meaning of HCl? What is the overall charge on HCl? Zero. Yes. So that means it has been cancelled. How it is cancelled? This is plus one. This is minus one. So plus one would be cancelled by minus one, and we are going to get zero. All right. Now, Somia, if I remove this hydrogen ion, what is left now?
Cl minus.
So can you see Cl minus here?
Yes.
So, what has actually happened? Hydrogen as a proton or hydrogen as an ion is given by acid. That is why it is called as an acid. The thing which loses hydrogen positive is called as an acid.
Okay.
Should I repeat again?
No, I understand it.
All right. How can you? This is. Should we go to the next question then?
Yes.
For each acid-base reaction in Model 2, describe the role of the Bronsted-Lowry acid in the hydrogen ion transfer that occurs. Now, what is the role of Bronsted-Lowry acid? You tell me. I have written here. What is the role of Bronsted-Lowry acid?
It donates a proton.
It's a proton donor. That's about it. Yeah.
Yeah.
So I will write it donates a proton. It's yeah, or it's a proton donor. And after donating proton, it is changed into what? An acid after losing the proton, it changes into what?
It turns into a base.
No, it turns into a conjugate base. HCl. HCl. H positive. After losing H positive, what will be left? Cl negative. So what is
So Cl
Cl negative?
minus, Cl minus is the conjugate base, HCl is
Well,
the acid, and then H um 30 plus would be the base. Sorry,
no.
H30 plus would be the conjugate base.
Yes. Now look, have a look, beta. This is acid. After losing the hydrogen ion, it will change into a conjugate base. Okay. Now this is a base. This is a base. After accepting hydrogen ion, it will change into a conjugate acid.
Okay.
Should I write it somewhere or is it clear?
No, it's clear.
Good. Question number 9. For each acid base reaction in Model 2, describe the role of Bronsted-Lowry base in the proton hydrogen transfer. I'll take one equation. Have a look. Let me rub this and let me pick this. Uh, okay. So I'll pick this. I hope I will be able to copy it. Hey, perfect. Now there is an example in front of you. So this is a Laurie Bronsted base. You know that this is a base. This is a base, yes? And this is an acid. Now, what is the work of Laurie Bronsted base? Laurie Bronsted base accepts hydrogen ion. Here, except proton. Have a look. Laurie Bronsted base does what? It accepts a proton or a hydrogen ion. Proton or a hydrogen ion, one and the same thing. Are you getting my point?
Yes.
So you will simply write Laurie Bronsted base is a hydrogen ion acceptor. That's it. And after, have a look now, this one. Here it is. This is a Laurie Bronsted base. So what it is going to do, it is going to accept hydrogen ion as a proton. So from where it is going to accept the hydrogen ion? From the acid. Are you getting it? And after taking or accepting hydrogen ion, this fluoride ion would change into what? Hydrogen fluoride.
Got it.
All right. And when it is going to lose hydrogen ion, it will be left with what? 1H, PO4. Now, don't memorize these charges. Try the proper way. Don't memorize the charges. You know that initially phosphate ion is -3. You know that. Yes?
Yes.
And how many you did it in chemical bonding chapter that PO4 has an oxidation number of -3. Do you remember that? 3 minus. Yeah.
Yes.
So you have already learned it. So how many hydrogen can you see here? How
One.
many hydrogen? One. So each hydrogen has a charge of +1.
Mm-hmm.
So now
Charge is
cancel. Now this plus would be cancelled by this negative. How many negatives are left?
2. So it'll be HPO4 2 minus.
There you are. Yes.
Yes.
So always start from the beginning. Otherwise, it will be difficult for you, honestly speaking, it will be difficult for you to learn the charge here. H2PO4 minus, then HPO4 2 minus, then H3PO4 0. It will be difficult for you. Only learn that PO4 is 3 minus, and then set accordingly. If two hydrogens are given like this, so it means there are two positive ions. So rub this or cut this. So two positive ion like this and three negative like this. So cut one with this, cut the other with this, and HPO4 would have only one charge, that is minus. Is it clear?
Yes, it's clear.
Good. I hope it's clear. Good. Now, next one. 10th question. As you saw in Model 1, all Arrhenius bases in Model 1 have a hydroxide ion. Now, you know what? Be very careful. I'll write it here. One model is Bronsted-Lowry model, and the other model is Arrhenius model. Now, have a look. There are again two things in it, acid and base. And this one also has acid and base. In Bronsted-Lowry model, acid is proton donor and base is proton acceptor. In Arrhenius model, acid base is hydroxide ion donor and acid is hydroxide ion acceptor. So can you see that there is a donor word, there is an acceptor word. There is a acceptor word, there is a donor word. Are you getting my point?
Yes.
So I have where it is written, let me show you. Uh, Here it is. Have a look. Arginious acid or a base. Have a look. So this is Arginious base giving OH negative. All right. Okay.
Okay.
All right. Good. Yes. So if you uh, um, write a balanced equation, chemical reaction for the reaction of HCl with OH. Now, beta HCl plus OH negative. This is equals. This is equals. Now, you know that this is a
HCl is HCl
yes.
is the acid and OH minus is the base.
Base. All right. So, what is going to happen? It is going to lose hydrogen ion. It is going to accept hydrogen ion, right? And after, so it is going to form Cl negative, Cl negative, and this would form H3O positive, right? Is it clear?
Right.
But in this case, have a look. In this case, we have already been given a OH negative. So when this H positive will go to this OH negative. So OH negative plus H positive. Charges would get cancelled and H plus OH makes up water, H2O, right? If you are confused that first we wrote H3O positive, so that is when H2O is given. So I'll write side by side. Let's suppose the question is given as HCl plus H2O. Then the answer would have been Cl negative plus H3 O positive. Please compare these two reactions. What's the difference? Here is OH negative and here is water. So water changes into H3O positive and OH negative changes into H2O. Does it make sense?
Yes. So how do we know that it will be H2O on the other side of the equation?
Because you need to, acid is always a species which is going to give hydrogen ions.
Okay.
Right? So as it is a species which is going to give hydrogen ion, so if it is going to give hydrogen ion to this, it changes into water. So that is why I disagree with this equation which is written by your teacher. Again, there is a very slight difference. Still, you are going to memorize it like this: that water acid is a species which is going to donate hydrogen ion. It will remain the same.
Okay.
All right. So, although it is not written in your syllabus, but if you are going to keep this, it will be easier for you to understand that acid is a species which donates hydrogen ion. Acid is a species which donates hydrogen ion. Is it clear?
Yes, that's clear.
Yeah. So keep this thing in mind that acid is a species which donates hydrogen ion. Now, next reaction. Should we go to the next one? All right. Somya, have you? I hope that you have seen the difference between these two OH negative and water.
Yes.
And you know that OH negative changes into H2O and H2O changes into H3O positive after accepting a hydrogen ion.
Right.
Good. Now the next one. If you reverse reaction 1 in model 2, the following reaction is obtained. He's asking you that if you are going to reverse this reaction in model reaction 1 in model 2. So what is reaction 1 in model 2? This reaction. Yeah. He's saying if you
Mhm.
are going to reverse this reaction, he has also given, here it is, if this reaction. If you reverse reaction 1 in model 2, the following reaction is obtained. For the reaction above, which reactive species reactant is acting like a Bronsted-Lowry acid? This is the main word. Which is Bronsted-Lowry acid and why? Or how can you tell?
The Bronsted-Lowry acid is H3O plus
Well done, well done.
because it's
Because it,
donating.
well done, shabash. Because it is donating hydrogen ion. Yes?
Right.
To what? To Cl negative.
Right. And
And
Cl
after,
negative is base
yes,
because it's
yes,
accepting a proton.
well done, well done. So this is an acid. and this is a base, and chloride ion is going to accept hydrogen ion, and after accepting it changes into what? HCl. And H3O positive after donating hydrogen ion, it will be left with, after donating hydrogen ion, it will be changed into H2O. Yes or no? And have you observed that this positive charge is now removed?
Yes.
Why? Because hydrogen ion has been given out. Yes?
Yes.
So should I write that for which is Bronsted-Lowry acid H3O positive or hydronium ion? Why? How can you tell? As it donates
A
hydrogen
proton.
ion or proton. Yes, a
So
proton slash proton.
if it's donating a proton, does it always have to be a hydrogen ion that's donated?
Yes,
Okay.
always. For the reaction above, which reactant is acting like a Bronsted-Lowry base? We have already talked about it. Which is Bronsted-Lowry base?
The Bronsted-Lowry base in this is Cl minus
Well done. So I will write Cl minus. And why?
because it's accepting a proton.
Excellent word. As it accepts a proton. I hope it's all clear.
Mm-hmm.
Write the reverse reaction for reaction 2 and reaction 3 in model 2. Label the Bronsted-Lowry acid and base. So we need to write down the reverse reaction. Let me copy reaction 2 and reaction 3. I'm very satisfied that you have already have got the document. So if I'm going to rub off anything, it will be there in the previous document. Yeah.
Yeah.
So I'm rubbing this off. So just to get, because I want you to make the equation. So first I'm going to copy the reaction 2 and reaction 3. So first let's copy reaction 2. Putting it here. I will rub it afterwards. Can you write the reverse of the reaction which is shown here? Can you see the reaction where this is the reaction? You need to write the reverse of this reaction. Yes, please make me write.
Okay, so the reverse reactions would be, could you scroll up to 2 and 3?
Sorry?
For 2 and 3, what were the reactions, the original ones?
No, no, reaction 2. This is here, reaction 2. You need to make a reverse of it.
Okay, okay. So if it's being reversed, it would be so NH3 is the base and HF is the acid. So that
No, no,
means,
no, 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 no. Somia, first you need to reverse it. So the products would become reactant and reactant would become product.
okay, so NH4 plus F minus would become HF plus, would become NH3 plus HF.
NH3 plus HF. First you need to write equals, 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 and equals. Now they are asking you to label the Bronsted-Lowry acid and a base. Now I will rub this. Okay. Now tell me which is the Bronsted-Lowry acid and which is Bronsted-Lowry base.
The Bronsted-Lowry acid is NH4 plus,
So this is
and
Bronsted-Lowry acid.
and the base is F minus.
This is Bronsted-Lowry base. Yeah. And after, if it is an acid, this NH4 positive is going to give hydrogen ion. Yes, beta. If this is a
Yes.
Bronsted-Lowry acid, it will give hydrogen ion. So hydrogen ion, if hydrogen ion will be taken out, it will be changed into what? NH3. So Mia, if it gives hydrogen ion, if it donates hydrogen ion, what will be left? NH3 will be left, beta.
Right, which is now the conjugate base.
Which is, yes, which is now the conjugate base. So this is Bronsted-Lowry acid and this is conjugate base. And if this is a Bronsted-Lowry base, this one would be conjugate acid. Okay.
Okay.
Now for reaction 3. I'll simply copy this reaction from here. You will tell me everything. First of all, you will reverse it. I'm talking about this reaction, Somya. This reaction.
Okay.
Okay. So let me copy this and then I will paste it there. First, you will make a reverse of it, and then you tell me which one is uh, conjugate acid and which one is conjugate base. So I'll put it here and then make me write down the equation. Yes.
Okay, so the reversed equation would be H3O plus aqueous
No,
plus
first write this.
okay, so it would be H3O plus NH3 equals H2O plus NH4 plus.
Yes. Now tell me what is an acid and what is a base in it.
So H3O positive is the Bronsted-Lowry acid and NH3 is the Bronsted-Lowry base. So H2O
Well
is the
done.
conjugate base and
Excellent work.
H4 is the conjugate acid.
Well done. So it is going to give hydrogen ion, and that hydrogen ion will be taken up by NH3 and it would change into NH4 positive. And after losing hydrogen ion, this H3O positive changes into water. Does it make sense now?
Yes.
Good. Should we start model 3 now?
Yes.
And I think there is no need to teach this model because I have already taught you this. Yeah, you have already done this. Have a look. Bronsted-Lowry acid, and this would be Bronsted-Lowry base or a conjugate base. And this is Bronsted-Lowry base, so this would be conjugate acid. If you remember, I told you the thing, for example, what is given? HCO3. So HCO3 would do what, Zomia?
It would donate a proton, a hydrogen ion.
It- Yes, it will donate a hydrogen ion. After donating hydrogen ion, it will be left with what?
CO3 2 minus.
Yes. So this is the conjugate. This is an acid and this is the conjugate base. Yes.
Yes.
And if this is a base, this one would be conjugate acid. Here it is. So now I'm going to rub this off. Uh, here it is. So can you see this?
Yes.
Okay, good. So should we start
So,
doing the question? Yeah, yeah, sure. Ask.
just a question. So CO3 2 minus, for example, is, or sorry, for H3O plus, H3O plus is the conjugate acid in this situation, but if the equation was reversed, then it would be the base.
If you reverse this equation, let's write it. Let's write it. I'll write it here. So if you reverse this equation, if you reverse this, it becomes H3O positive plus CO3 2 negative changes into HCO3 negative plus H2O. Yes, this would be the reverse equation, Somya.
Yes.
Yes. Now tell me, what
H3O
H3O
plus,
positive is? It is going to donate hydrogen ion,
yes. So it would be the acid.
and so it will be acid, and it will change into what? Water. So this is the conjugate base. All right.
So,
Uh, yeah.
so the conjugate acid is still technically an acid if the reverse, if it's still technically an acid.
Have a look. H3O positive here is an acid. All right. And here it is what? Here H3O positive is what? Conjugate acid. And here it is an acid. Are you getting my point?
Yes.
And this CO3 2 negative is a base. After accepting hydrogen ion, it changes into HCO3. So if it's a base, let me write, if it's a base, then this is conjugate acid. Yes or no?
Yes.
So now check. This is conjugate acid, and in the previous reaction, it was only acid. Here it is. It's a conjugate acid in this reaction, but in the previous reaction, it was only acid.
Okay, so it just depends on the order of the equation.
Yes. And
Got
if
it.
it's a base, have a look, beta. If it's a base, in CO3, 2 negative is a base here. Here, what was it? Conjugate base. In the previous reaction, it was conjugate base. Yes or no?
Yes.
Any confusion?
Nope.
Good. Now I am rubbing this. Okay. Oh, yes. All acid-base reactions have. Okay, now I'm going to rub this off just to solve this question. Okay, now please read the question, Somya. 13.
All acid-base reactions have two conjugate acid-base pairs. One conjugate acid-base pair in the reaction in Model 3 is H3O plus H2O. List the other acid-base pair in the reaction. Okay, so in Model 3, the other acid-base pair is uh, okay, so they listed H2O plus and H2O. The other one is HCO3 minus and CO3 2 minus.
Well done, well done. So 8CO3 minus and CO3 minus 2. I hope you have got it.
Yes.
They have given this pair. They have given this pair. Have a look. Yes?
Mm-hmm.
So which pair is left? This pair.
Okay.
Should I explain again?
Nope, I understand it. I'm just writing it down.
Okay, okay. I thought that you are still thinking about it.
No, no, I understand it.
All right, good. So why is 8CO3 negative considered the acid part of the pair in the reaction in model 3?
Because it donates a proton.
Because it still has a hydrogen. Can you see this hydrogen?
Yes.
So it can still give a it can still donate a proton. That is why it is considered as an acid. Yes,
Yes.
it can still give a proton, or donate will be better word. Donate a proton. Should we go to the next question?
Yes.
Why is carbonate considered the base part of the pair in the reaction?
Because it accepts a proton.
It accepts a proton. Should you do you want to do the next part, or should I move to the next question?
Nope, we can move to the next question.
Which one should we start? 17th or 18th?
17.
All right. So examine the charges on the species in the Model 3 reaction. Why does the charge on the carbon containing ion change from -1 to -2?
Because it
Uh,
donates a proton, so it now needs two protons to achieve stable.
yes. So it was actually, what was it? It's CO3 negative. So when it will donate a proton, it will change into what? CO3 minus 2. Yes,
Yes.
that's it. From -1 to 2. And if you want me to, is it all clear? Or
Yes.
if you want me to explain it, so it is 8CO3 negative. So originally it was what? Originally it was H and CO3 2 negative. Do you remember? I always tell you from the original value. Yeah. So what does it mean? It means that HCO3 means minus and minus. And what would be the charge on hydrogen? Plus. So one, yes or no?
Yes.
Oh, just a minute, just a minute. Yeah, HCO3. So that means that H1 would be cancelled. No, we need to do it like this. All right. So if HCO3 is given to us, HCO3. Now when this hydrogen would be taken out, that means one positive charge would be lesser. So one negative charge will be added to it. So it would become -2. From -1, it would become -2. Is it clear?
Yes, that's clear.
All right. Using the list of the substances below, select pairs that are conjugate acid and base. Enter the pairs in the table shown below. The first acid base pair has been entered for you. Note that you may use a substance more than once and not at all. So if the first one is H3PO4, the pair would be the conjugate base would be H2PO4 minus. All right. The next
Yes.
one. H3O positive. So if I'm talking about this one, all right. So H3O positive. So what would be the conjugate base? It is going to lose a hydrogen ion. So after losing hydrogen ion, what will be left?
H2O minus
H2O. Well, no, that's about it. Why minus?
because it loses a proton.
So that is the after losing the proton, what would happen? Nothing. H2O is already neutral. +2 -2.
Okay.
Yeah, it's already neutral. Now the next one. What is the next one? That would be, you tell me what to pick now.
We'll do NH or HPO4 2 minus,
HPO4 2 minus.
and that's an acid. Yeah.
Yes, that's an acid. So
So it's going to donate a hydrogen proton, so it'll become PO4 3 minus.
3 minus, yes. That's it.
And then the next one, H uh 2CO3,
H2CO3.
which is an acid.
Hmm.
So it's going to donate a hydrogen proton and it'll become HCO3, just HCO3.
Minus.
Right, because it loses a proton.
Yes. Next.
Okay, we can do CO3 2 minus, which is a conjugate base.
CO3 2 minus. You want me to write it here?
Yes.
Okay.
And then the acid for that would be HCO3 3 minus.
No, HCO3 minus.
Oh, right. Okay.
But it is not given in the list.
Um,
CO3 minus 2 is not given in the list. Hmm?
then what would be the acid for CO3 2 minus?
No, you gave me the correct answer, but it's not given in the list. We need to pick from the list.
Oh, CO3 2 minus is in the fourth column.
Yeah, I know, but for CO3 minus 2, the acid is not given in the list. Have a look.
Oh, not all of them will be used. Okay, I see.
Yes.
Okay, then CO2.
Let me check just a minute. You did H2CO3. H2CO3 and HCO3 minus. HCO3 minus. Beta, you can't do you can't use this as well. Can you see H2CO3 is not there in the list? This one. Can
Yes.
you see? So you can't. All right. So HCO3 minus. Can you see HCO3 minus somewhere here? This is here. Where is HCO3 minus? Can you see it?
Yes.
Where is it? Soumya, can you find HCO3 minus in the list somewhere?
Um, no, I don't see it.
So then you can't use it. H2CO3 is here, but the other part is not in the list.
Okay, but is that the correct answer regardless of the list?
We need to pick those conjugate acid or base pair which is there. Both of them should be there in the list. If one is missing, we can't pick that.
Okay, then let's see if H2O, so H2O would be a conjugate base and its acid would be H3O,
Positive.
would be H3O plus, which is that's in the,
Yes, absolutely right. So what should I write? H3O positive. Where is it? H3O positive. Where is it? Here it is. And then we have done that already. Second number. Soumya, we have done that.
oh, okay. Then NH3 is an acid, or sorry, yes,
Yes.
it's an acid and its conjugate base would be NH2 minus, which is in the list.
And it's three. Yes, absolutely correct. So let me highlight this one and this one. The second one is H3PO4 and H3PO4 minus, and then comes NH3, done. HPO4 2 minus, done. With HPO4 minus, fine. Is it clear?
Yes.
What else? We,
Okay.
we are left with three.
OH minus is a conjugate base, and its acid would be H2O.
Okay, good.
And then C2H3O2 minus is an acid, and its conjugate base would be C2H2O3 minus, but that's not in the list. Um, NO2 minus is a conjugate base, and it would be HNO2 positive, but that's not in the list. Um,
And
H2CO3 would be would become HCO3 minus, but that's not in the list.
yes.
CO3 2 minus would be HCO3 minus. I don't
Mm-hmm.
see that. Um, PO4 3 minus is
Yes.
conjugate base,
Conjugate.
and it would be HPO4 2 minus.
Yes. Well done. It's there.
Okay.
Yes. And one is
Yes.
left now.
Okay. CO2 would be a conjugate base and it would be HCO2. Oh, that's not in there.
Now this is left only.
Okay, so that would be an acid and its conjugate base would be H2C2O2 minus.
Yep. Correct. So I will write H2C2H3O2 and its conjugate base would be C2H3O2
H2H2.
minus. Is it clear now?
Yes.
Well done. Should we do 19th?
Yes.
All right. So write the formula for the conjugate base of each of the following acids and be sure to consider the charges. HCO3. So conjugate base. We need to write down the formula for the conjugate base. Now, after losing hydrogen as an ion, what will be left?
It will be SO3 2 minus.
Well done. After losing hydrogen ion.
F minus.
Well done. After losing hydrogen ion.
S minus. S2 minus.
S2 minus. All right.
Yes.
Next, write the formula for the conjugate acids of each of the following.
Okay, so it would be
You will
HCO3.
you will add hydrogen ion. Yes?
Oh, sorry, I was doing the wrong one. Okay, the conjugate acid would be HSO3 minus,
Yes.
and then F minus would be HF positive, and then
No, no,
HS,
not positive. Not positive, Betty. One positive would get cancelled by negative.
oh, just neutral, no charge,
Neutral list. Yes. And this one?
would be um H2S
Yes. So
positive.
what is the trick? No, 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 nothing. Have a look. Let me tell you the trick. Beta, the trick is just check H, this one. Check this one. HSO3 minus. When you add, when you make it a base, what you do? You subtract what? You subtract hydrogen ion. Yes? So hydrogen ion carries one positive. So what you do? You add one negative here. So if you are taking out positive, you will add negative to the other side. If you're taking out negative, you will add positive to the other side. Are you getting my point?
Yes.
So let's suppose HF. Now check this HF. Now this contains nothing. All right. So when you move hydrogen ion, if you remove hydrogen ion, it means you are removing plus one charge. So you will towards the other side, you will add minus one charge. So it would become F minus one. No?
Okay. No, I understand.
And for this one, have a look. You have SO3 2 minus. You will add H positive. When you will add H positive, what you are going to do, you will subtract plus 1 from here. So it would be minus 1.
Okay,
This is the key.
go ahead.
I think I should explain again.
So if it has a minus charge for example, HS minus, and it gains another hydrogen because it's becoming a conjugate acid, then that hydrogen has a positive charge. So the positive charge and the negative charge cancel out, and it now has a neutral
Yes.
charge. Got it.
Yes.
Okay.
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 Next question.
Okay. For the following reactions, label the acid and base in the reactants and the conjugate acid and conjugate base in the products. So HCO3 minus is an acid, and its conjugate base is CO3 2 minus.
Well done. This is conjugate base. And what is this? It's a
That is
base.
that's the base, and NH4 plus is the conjugate acid.
Well done. Well done. Now, next part.
Okay, HCO3 minus is the acid, and the conjugate base is H2CO3. Or wait, no,
Yes.
HCO3 minus is the conjugate.
Beta, what is this?
That's an acid
Why?
because it has, no, it's a base,
Yes, it's a base.
and HCl is an acid.
Yes. So base changes into conjugate. Oh, sorry. Base changes into conjugate acid. Yeah. And acid changes into conjugate base. Yes.
Yes.
Last question, 22.
Is the role of a conjugate acid in the reverse direction the same as the role of an acid in the forward direction? Um, yes, it is the same because it both a conjugate acid in the reverse direction and an acid in the forward direction donate a proton
Well
to.
done. Very well done. Good. Yes, as both the conjugate acid and acid donate a proton. Is it clear?
Yes.
So I hope that this whole worksheet is clear to you. Yes.
Yes, it is.
Do try to do the question extension question. Did your teacher ask you to do the extension question or not?
No, he didn't, but I'll do them.
All right, try it out and then do this
Okay.
for the homework. Try this one as a homework. If you will be able to, no, Soumya, you won't be able to do that. Okay, leave it. We will do it tomorrow. Okay.
Okay.
All
I'll do the
right.
extension questions.
Yeah, sure. Do the extension question. If you are able to do them, fine. If not, it's okay. All right. Because your teacher has not asked you to do that.
Okay.
Okay. All right, Soumya, I hope that you have understood the lesson well.
Yes, I did. Thank you.
Welcome, welcome. Okay. Take care, Bete. Bye bye.
Thank you. Bye-bye.